All right, so today we're going to look at the implicit differentiation again, but this is the second derivative implicitly. So we're going to start off by doing what we did in our previous lesson. We're just going to take the derivative. We're going to find dy dx. So if I do that with this equation, x squared plus y squared, the derivative of x squared is 2x. The derivative of y squared is 2y, as we learned yesterday, times dy dx. Okay, that's the derivative of y with respect to x, and that's going to equal 0 because the derivative of 25 is 0. Now, today what we're going to want to do is get the dy dx by itself, so I'm going to subtract 2x on both sides. That's going to leave me 2y dy dx equals 2x, or excuse me, negative 2x, and then I can divide out the 2y on both sides, and that's going to leave me dy dx equals negative 2x over 2y is just simply going to be negative x over y. So there's my first derivative implicitly, and now we want to take the derivative of that. So what it's basically asking me to do is say, let's take d dx, the second derivative of this function. When I do that, I'm going to end up on the left with d2y over dx2. All right, notation's a little funky, I know that, but we won't worry so much about that. Now on the right side, when I go to take the derivative of the right side, I need to do quotient rule. So the derivative of the top, that's going to be negative 1 times the bottom y, minus the top, so that's minus negative x, times the derivative of y, that's dy dx, all over the denominator squared, which is y squared. Now, in this case, I know that dy dx is equivalent to negative x over y, so I can do a little bit of substitution here. So I'm going to do that next. I'm going to substitute, and I'll clean up the top. This is negative y plus x. Substituting for dy dx, I'm going to substitute in negative x over y. And then the denominator I can just leave as y squared. But maybe this is a multiple choice question and I need to clean this up even more because we have some improper fractions and things like that going on. So what I'm going to do next is I want to cancel out this y in the denominator up here. So I'm going to multiply the numerator by y over 1. And so I'll multiply the denominator by y technically over 1. So here we go. I need to do a little bit of distribution here. So this would now be negative y times y, which is negative y squared. And really, if I wanted to be perfectly mathematically correct here, I should probably have some parentheses around here. Okay, so I am distributing. Let's see. The y's are going to cancel out in this second multiplication, but I do have x times negative x. That's negative x squared. In the denominator, I now have y cubed. Okay. But maybe I'm not even done there, because take a look at my numerator. If I factor out a negative 1 in the numerator, I've got y squared plus x squared. Now, normally I wouldn't do this, but on a multiple choice test, they do a lot of simplifying here, because if you take a look back at our original problem, look at that original problem, x squared plus y squared equals 25. So what I've seen them do a lot on these tests is this. Let's see if we can get rid of that. There we go. They will take out the y squared and the x squared. They'll replace it or substitute negative 1 times 25 over y cubed, which then just leaves me negative 25 over y cubed. Okay? On a multiple choice, you wouldn't necessarily have to do that, but on a on a multiple choice, you probably would have to do that. On a free response, most likely not. All right, so I would encourage you to try the next one on your own. It works pretty much the same way. This time we're going to start off with the derivative 2x minus 2y equals 0. Oops, what did I forget already? dy dx, right? dy dx equals 0. I'm going to subtract the 2x, so that's going to give me negative 2y. dy dx equals negative 2x. And then if you divide out the negative 2y, you get dy dx equals positive x over y this time. So there's my first derivative. My second derivative, now we'll go over here to the right. We're going to calculate d2y over dx2. So this is the second derivative using x over y. So again, quotient rule here, derivative of the top times the bottom, 1 times y, minus the top, the numerator, times the derivative of y, the bottom, denominator, that's dy dx again, all over the denominator squared. All right, here we go. Cleaning up the top, I would have y minus x. I'm going to substitute in dy dx again. That's x times y, or excuse me, x over y. Just like that. I don't need the parentheses. I didn't put them there this time because there's no negative in between. All over y squared. I would do the same thing that I did on the last problem. I'm going to take and do a little bit of multiplication, y over 1 in the numerator and y over 1 in the denominator. And I end up with a very similar situation as the last time. I have y squared minus x squared, because the y's are going to cancel out, all over y cubed. And then again, if I go back and look at my original problem, notice my original problem this time said x squared minus y squared. Okay, well that's not exactly what I have, but what I can do again is I can factor out that negative 1. That's going to give me negative y squared plus x squared, which is equivalent to what I started with, x squared minus y squared, all over y cubed. And then again, I can substitute 9 for x squared minus y squared, and 9 times negative 1 is going to give me negative 9 over y cubed. Okay, not so bad, is it? All right, let's take a look at this next one here. So, okay, so we're back for our next one. At this point, you should definitely try and turn off the video and try this, but we want the second derivative. It does say simplify as much as possible. So here we go. Derivative of x squared is 2x plus the derivative of 4y squared is 8y dy dx. And that's going to equal 0 again. Now, this time we need to subtract 2x and divide by 8y. So I'm going to do all of that at once here. dy dx. If I subtract the negative 2x, or excuse me, if I subtract the 2x, that's negative 2x. And if I divide out the 8y, I end up with dy dx equals negative 1x over 4y. So there's my first derivative. Now I need my second derivative, so we'll do that one next. And second derivative, d2y over dx2. All right, here we go. The derivative of the numerator, that's negative 1, times the denominator, that's 4y, minus the numerator, that's minus negative x, times the derivative of the denominator is going to be 4 dy dx. Okay, so the 4 is going to stay there. That's going to be over 4y, and that 4y is now being squared. So now I need to substitute for dy dx. I'll clean up my numerator a little bit. That's negative 4y plus x. Actually, I can do this. I can do plus 4x times dy dx, which we know is negative x over 4y. So we're going to end up multiplying by that. And then in the denominator, I'll go ahead and square 4y. So that's 16y squared. Now, just like before, I want to get rid of this 4y down here in the denominator, so I'm going to multiply by 4y over 1 in the numerator times 4y in the denominator. And again, I'm doing that to the entire fraction here, numerator and denominator. So 4y times negative 4y is negative 16y squared. The 4y's are going to cancel on the right. That's going to leave me negative 4x squared. And the denominator is now 64y cubed. All right, so at this point, I can, let's see here. Let's see what we've got to clean up here. So I'm going to come over here. Okay, now my original problem was positive x squared and positive 4y squared. So I'm pretty sure that this time I can cancel out, or not cancel, but factor out a negative 4 from the numerator. That's going to leave me 4y squared plus x squared, which is what I started with. Remember, that was equal to 1 all over 64y cubed. So I'm going to substitute, well, first thing I'm going to do is I'm going to simplify the negative 4 over 64, so that the negative 4 in the top is now negative 1. The 64 in the denominator becomes 16. And then I can substitute inside the parentheses 4y squared plus x squared was equal to 1. Back from the very beginning was equal to 1. So I've got negative 1 in the numerator and 16y cubed in the denominator. Okay? If you like that one, this next one's a lot of fun here. All right? This one specifically says do not simplify, and you'll see why in just a couple of minutes here. The first thing it says is calculate y double prime. So I need the first derivative, and now I've got product rule as I implicitly differentiate. So I need to be very careful with both of these terms when I do my first derivative here. Here we go. I need product rule. The derivative of x squared is 2x times the second, that's y, plus the first, that's x squared, times the derivative of y, that's dy dx. I go to the next term and I do the same thing. The derivative of the first is 3 times the second, y cubed, plus the first, 3x, times the derivative of y cubed, which is going to be 3y squared dy over dx. And again, the right side turns out to be 0 here. Not too bad there. Now, to get dy dx by itself, I need to subtract 2xy from the left. So I'll subtract it on the right. I also need to subtract the 3y cubed right here. So we'll do that on both sides. So on the left side, I have x squared times dy dx left. Going further down the line, I'm going to multiply some of the, let's see here. I've got 3x times 3y squared, so that's going to be 9xy squared times dy over dx. And that's going to equal negative 2xy minus 3y cubed. Now, it did say not to simplify, but I have to simplify before I take the second derivative so that I can get the dy dx. I need to get the dy dx by itself so that I can take the second derivative. All right, so my next step here is going to be to factor out the dy dx. So I've got dy dx. I'm going to factor that out on the left. That's going to be times x squared plus 9xy squared. On the right side, we still have negative 2xy minus 3y cubed. All right. Last step to get dy dx by itself is to divide out the x squared plus 9xy squared on both sides. So I want to divide that out, so I'm just going to do that. I'm not going to show all that work because I'm running out of room here. But the right-hand side now stays the same in the numerator, but I'm going to divide out the x squared plus 9xy squared. And now I'm ready to do my second derivative. This will be the fun one here. I'm going to start way over here on the left side of the page and hope that I have enough room here. d2y, second derivative with respect to x, dx2. All right, so now we have quotient rule, product rule, chain rule, or excuse me, quotient rule, product rule, and chain rule all wrapped up here. So I need to be really careful. I need the derivative of the numerator. The first part of the numerator includes chain rule and product rule. So here we go, very slowly. We're going to do this piece right here. The derivative of negative 2x is negative 2 times the second, that's y, plus the first, which is negative 2x, times the derivative of y, that's dy dx. I'm not even done yet here, guys. I need the derivative of the second part here too, minus 9y squared times dy dx. That's the derivative of just the numerator. Okay? Now I need to multiply all of that by the denominator. That's going to be x squared plus 9xy squared. Then I'm going to subtract the numerator, negative 2xy minus 3y cubed. And now I need the derivative of the denominator. So I'm going to multiply. The derivative of x squared is 2x plus, now I've got product and chain rule again in this second part, so I got to be really careful. The derivative of 9x is 9 times the second, y squared, plus the first, 9x, times the derivative of y squared, which is 2y dy dx. That, ladies and gentlemen, is your quotient rule and chain rule and product rule all wrapped up into one big problem. The denominator is the easy part because it's still all over the denominator squared. And that is second derivative implicit.